Hello world, it's Craig. This is the schematic for the 1950s Western Union Desk Fax. It's essentially the first personal fax machine, and I did an overview of its physical operation in an earlier video. Now is the time to see exactly how this device works from an electronic perspective, how it transmits the image, and the control interface with the central office. I'm going to break this operation of this device and this circuit down into 4 separate videos. Now, this video is going to be an overview of the system and a description of how not only the facsimile data is transferred, but how the central office simultaneously controls this unit with everything going over just the 2-wire subscriber circuit. The second video will be the control system and the sequence of events in this circuit that occur when the subscriber sends a fax to the central recorder. Then a video when the fax is going the other direction, and the sequence events when the central office sends a fax to this subscriber's machine and this becomes the recorder. And finally a video on the power supply, amplifiers, and data transfer of the facsimile image itself. I need an understanding of all this before I can start designing the central office wannabe circuit that I suggested as an end goal in my video earlier on this machine. We need a central office so that these machines can have something to talk to, since there's issues with peer-to-peer operation. The primary function of this circuit is the data transfer of the facsimile image, so let's go over that first. In the last video on this system, I went over the physical aspects of how a transmitted fax gets loaded and sent, including reading off the paper, and how the received fax gets printed. In both directions, it's a 2400 Hz audio signal. When sending, a tone means there is a white area on the fax, and silence on the line transmits a dark mark. It's the opposite when receiving. A tone tells the recorder to create a mark on the paper, and silence leaves the paper unmarked. First up is how that audio tone itself is conveyed between the central office and this machine. The machines on both ends have transmitting and receiving amplifiers that are transformer coupled to the subscriber loop. It's a typical 2-wire subscriber loop, and it can have up to about 3K of resistance. When this sends a fax, the transmitting amplifier tube drives this output winding in the line coupling transformer, which in turn drives the secondary subscriber line winding. That applies a voltage to the subscriber line, which results in a current in this loop that goes between this machine and the central office. At the central office, this current in the subscriber's loop goes through the line winding in the recorder's line coupling transformer. Then it creates a voltage in the receiving amplifier winding, which is amplified and used to print on the paper. The exact same process when going the other way. The unit switches over to its receiving amplifier, and the transformer is now an input. The central office connects to its transmitter amplifier, and now the central office is driving this current loop through the subscriber line. In practice, this unit was plugged into the subscriber line, and the operator selects the function by pressing the incoming or outgoing buttons. At the central office, the line terminated with a patch cord, and the central office operator will physically connect that subscriber loop to either a recorder when a fax is incoming or to a transmitter when a fax is being sent to the client. Now that's all I'm going to get into on the data transfer for this video. We'll get into the details of the amplifiers in the 4th video, but you get the concept that an AC current signal is driven in this loop going between this device and the central office. So that's how the data is transferred. Now let's look at how the central office simultaneously sends control signals and receives status signals across these 2 subscriber loop lines, even while the data is being transferred. To this subscriber loop, on the transformer winding that's attached to the loop, meaning on the central office side, not the amplifier side, let's put a contact to the winding at its impedance midpoint. A center tap, if you will. And let's do this on both ends. And this circuit also requires a return path. It's just going to use the return ground for the 0-volt connection, and since the AC mains are not grounded, or even polarized for that matter, the ground was most likely just created locally. Now, if we connect this tap to a voltage source on one end and a load on the other end, a DC current will flow in the subscriber loop, in addition to the AC current that's transmitting the fax data. But that DC current isn't flowing around the loop, it's flowing in the same direction in both wires, from one end to the other end. Also, since we're injecting that current and sinking the current at the midpoint impedance of the winding, Pretty much by definition, half of that current is going to go through each wire in the subscriber loop. At the other end, the two half currents rejoin and come out the other center tap to go through whatever load is connected, and then the current goes to the zero ground connection. But, and this is key, of course, all the currents are additive, and since the two current halves of the DC current are going in opposite directions in their windings of the transformer, their influence on the amplifier winding is canceled. This top half current creates a DC voltage in the amplifier winding with the top being positive, while the bottom half current induces a DC voltage in the winding with the top being negative. So these two DC currents exactly cancel each other out. Only the loop current is picked up by the amplifier, and that common mode DC control signal is not detected by the amplifier. Now, the central office could get as sophisticated as they needed with this current signal. They could have different voltage levels, different current directions, source the current on either end, and create as many different unique combinations as they needed. But in practice, Western Union found that they only needed a positive voltage and a negative voltage, and both of these can just be supplied by the central office. The next hurdle is for the Desk Fax to send its status back to the central office. As it turns out, the requirement was very simple. So just like a telephone hook, the Desk Fax can give its status by either allowing the DC current to flow or opening the circuit so that there is no DC current. To detect that status signal from the Desk Fax, Western Union may have had something more complicated, but in our little example, we can just demonstrate this by just putting in the coil of a DC relay in this circuit at the central office end. And I'm going to call this the status relay since it indicates the status of the Desk Fax current. Then at the central office, the recorder or the transmitter applies either a negative or a positive voltage to the center tap through this relay coil. If a voltage is applied and the circuit is complete, then current flows and the status relay closes. Now, depending on why the central office was applying that voltage, what state the machines were in, the Desk Fax is giving a corresponding status to the central office. But if the Desk Fax needs to send the other status, then it leaves the circuit open, and as the central office applies the DC voltage, no DC current flows in the circuit and the coil doesn't close. In other words, the central office is sending binary 0 or 1 by applying negative or positive potential to the control line, and then the Desk Fax is responding with the 0 or 1 by opening or closing the circuit to allow the current to flow or not. The only way this simple interface can convey enough information is because the whole combination is operating as a state machine, meaning each end knows that the other end is going through a sequence, through a process in a very predictable manner from one state to the next until the overall operation is complete. When a response comes back to the central office from the Desk Fax, what it means depends on the current state of the process. So for example, if the central office applies a positive voltage during fax data transfer and it receives a zero current response, then that zero current is a copy drum synchronizing signal. But if the central office applies a positive voltage when the Desk Fax is idle, then current will flow and the applied voltage sets off the buzzer in the Desk Fax to get the attention of the client operator. But do that same thing when the Desk Fax has its vacuum tubes already powered up, and no current will flow, indicating to the central office that the Desk Fax is not actually idle and something else is going on. Now, we'll get a full flavor of that interface in the next two videos when we go through the steps to send a fax from this machine and then to receive a fax when this is the recorder. And to get it worked out in my head, I started with 30 or 40 copies of the schematic and step by step worked through the machine's operation in the sequences. The transmit and receive sequences will be the next two videos, so you have something to look forward to. I'll put a link to this schematic in the description if you want to take a stab at figuring it out for yourself. It's from the May 1972 QST Amateur Radio Magazine article on how to convert the Desk Fax over to amateur radio use. Now, across the top of the schematic, we have the power supply on the left, the receiving or the recording amplifier in the middle, and the sending or the transmitting amplifier on the right. Only one amplifier is enabled at a time, so the transmit and receive amplifiers are simply connected together to this winding in the coupling transformer. And much of this in the middle part is how the machine progresses from one state to the next as commanded by the central office, or these front panel buttons. Nowadays we would just call this glue logic, but there's a lot going on here, and I certainly want to save most of this mess and divide it up between the next two videos. However, there are a few items that are fairly independent of everything else and do the same thing each time they operate, so we might as well go over those now and ease into this overall system operation. Here are the motors. This is the drum motor that rotates the copy drum. And evidently these units had a variety of motors, so there's two other motor diagrams up here. They have different support components, but they're nominally the same for our discussion. Here's the carriage motor that moves the carriage under the read and print heads, the stylus motor that puts the print head tip in contact with the teledeltos paper during printing, and the chopper motor that converts the steady light beam into the 2400 Hz signal when transmitting the copy. There are various contacts and relays. Some are DC and some are line voltage AC. Now they've drawn the schematic so that the normal position, the non-energized state, of all the contacts are away from the solenoid. When energized, the reed is pulled towards the coil. For many of the coils, they show contacts on one or the other or both sides, wherever they're convenient to the schematic, but in all cases, the terminal that's further away from the coil is the non-energized state, the normally closed state. And when the coil is energized, the reed moves towards the coil to that contact. These two front panel switches I showed earlier are the radio buttons for incoming and outgoing transmission, and both are shown in the non-selected state. Each button has 4 shorting blocks that connect 2 of its 3 terminals. Mechanically, the radio buttons are mutually exclusive, so the device is either in the sending mode, receiving mode, or it's idle when neither button is engaged. For example, this bottom left set of 3 is one function. The bottom terminal is the cathode of the transmitting amplifier. The center terminal is connected to ground. And when the button is not pressed, those two are shorted together. Then this upper terminal is connected to the cathode of the receiving amplifier. And when the button is pressed, those two, the middle and the upper one, are shorted together. So when the button is not pressed, the shorting block connects these bottom 2 terminals together and enables the transmitting amplifier by connecting the cathode of this half of the 12AX7 to ground. When the button is pressed, the second and third terminals are shorted together, which disconnects the transmitting amplifier and connects the cathode of this 6AU6 receiving cathode to ground, and that enables the receiving amplifier. That means that by default, the unit is in transmitting mode unless the receiving button is physically selected and the receiving amplifier is enabled when this incoming button is then pressed. That selection happens no matter what else is going on with the circuit. It's just controlled by this one button. And let's look at the bottom shorting block on both of these buttons. Now, all of this cross-connecting between the 2 buttons serves the same purpose. When neither button is pressed, this line input goes nowhere but to the bottom contacts. But these are mechanically wired as an OR device, so if either button is pressed, then this line voltage is applied to one terminal of this main power relay. The other terminal of that relay coil is always connected to the other line input. So again, that relay closes when either button is pressed, and that happens no matter what else is going on in this circuit. So if either button is pressed and the main power supply relay closes, then this switched leg of the power is applied to the main amplifier power transformer, and the other line input is directly connected to the power input, so the amplifier begins to power up. And again, that's no matter what else is going on in this device. But most other portions of the circuit have the second line input switched, which operates as an AND logic, meaning one button needs to be pressed and something else needs to occur before they're powered up. Now, there's no telling which of the inputs are line and which is neutral, because back then receptacles weren't polarized or grounded. Now, they did bring in a ground connection through the subscriber line connection, so this wasn't a floating chassis that you needed to try the plug put in one way and then flip it over if it either shocked you or if it had a hum. Over here on the right is the subscriber line loop transformer. And just as I described earlier, the amplifier winding connects to the 2 amplifiers. The subscriber loop side has the winding for the image data current loop and the center tap for the commands that are coming in as those DC common mode currents. And here's that ground connection that came in with the subscriber loop wires. The center tap comes into these 2 selenium rectifiers. And if you haven't seen a selenium rectifier lately, here they are on the device. The control line comes into these rectifiers, And if the central office is applying a positive voltage, then this top rectifier is forward biased, and the voltage is applied to whatever is connected in that top part of the circuit, and the current can flow out to the ground. If the central office applies a negative voltage, then current can flow from ground through this bottom rectifier and back to the central office. Of course, as I talked about earlier, once the central office applies the voltage, whether or not current flows depends on what the status this DeskFax wants to be sending back to the central office. So let's say that the central office has applied a negative voltage to the control line. If this DeskFax leaves that as an open circuit, then no current will flow, and that central office relay, the example that I showed earlier, that central office relay will not energize. And this is, in fact, the idle state of the machine. When in idle, the central office puts minus 120 volts DC on that line. The DeskFax leaves this as an open circuit, so no current flows, and there it sits. Now, if the status of this DeskFax changes, and somewhere in this rat's nest that line is grounded, then current will flow out of that ground through the selenium rectifier and then back to the central office. That current will make the central office status relay close, and the central office is now aware of our new status. And in fact, if that machine was in the idle state, the new status of the current flowing means that the client wants to transmit a fax to the central office, and that relay that closed can turn on a light. And then when the central office applies a positive voltage to the line, then this upper selenium rectifier is forward biased and the central office voltage is applied to this line relay. If the DeskFax leaves the other terminal of that relay open circuit, then no current flows through that line. But if it takes that terminal to ground, then current flows through from the central office, through this relay and into ground, and then this relay is energized and closes. Of course, it's at the same time, because current is flowing, the status relay at the central office will also close. Now, most everything else in the system depends on the state of something else in the system in a more complicated manner. And I can't think of any other basic elements of this circuit that we can understand without digging further into the operation, so I'm just going to leave it here for now. In the next video, we'll go through the sequence of events for this unit to send a fax to the central office. And it's really quite an impressive dance of relay and sequencing logic. I think it's very interesting to see how they did this and how it works. So that's it for this video. As always, this channel is not monetized and it's entirely fueled by your likes, shares, and subscribing. Thanks for watching. Talk to you later. Bye-bye.